Today we're going to be talking about 2D figures and their area and perimeter. Our objective is that we will be able to use formulas for area, perimeter, and circumference of two-dimensional objects to solve real-world problems. So area, which is represented using a capital A or sometimes a capital B, is the space covered in two dimensions. So they're all going to have square units. So units squared, meters squared, feet squared, centimeters squared, that sort of thing. And when you think of this, this is like if you were to paint a wall. Or carpet a floor. Perimeter, which is represented with a lowercase p, is the total length of all sides of a two-dimensional figure. It's a one-dimensional thing, so it will be just units, centimeters, meters, inches, etc. The way you can think of perimeter is a fence around a yard. Volume is the space contained in the interior of a solid. It is three dimensions, so it is units cubed or meters cubed, etc. With this one, you can think of filling a container, how much it can hold. Or liquid in a cup. Or how much water is in a pool. So we're going to be using the geometry formula sheet a lot in this unit. And here's 4 of the shapes we're going to be using today. This one has a rectangular base and it comes together at a point at the top. This is called a pyramid. It has one base at the bottom and a point at the top. Here we have a rectangle. This one has a base at the top and then also it has a base at the bottom. So it has 2 bases. And this is called a prism. And then finally we have our formulas for a triangle. Now this actually gives us 2 equations for the area. We're going to stick to the 1/2 BH and not worry about the 1/2 AB sine of C. So lots of abbreviations going on in these formulas. V stands for volume. LA stands for lateral area. SA stands for surface area. Lowercase p stands for perimeter. L in most cases is length. If you notice there's an L here and an L here, this is the length going down this triangle. This is the length here. So in general, it's length. W is width, how wide it is. Capital B is the area of the base, which we have in both our prism and in our pyramid. H stands for height. And lowercase b stands for length. of the base. So in this triangle, it's how long the base is. So a rectangular prism whose base measures 5 feet by 3 feet is shown. So one side is 5, one side is 3. Find the area of the base of the pyramid. So since this base is rectangular, we would be using the rectangle formula, and the formula for area is length times width. So it would be 5 times 3. So the area is equal to 15. We're always going to want to put units with our answers. So both of the sides were measured in feet. And then because it's area, we use 2 dimensions, so it's feet squared. Find the perimeter of the base of the pyramid. Again, because it's a rectangle, we use the formula for rectangle. Perimeter equals 2L plus 2W. P equals 2 times the length plus 2 times the width, which gives us a perimeter of 16, and perimeter is just 1 dimension, so it's 16 feet. Now let's look at the triangular prism shown. The fact that it's a triangular prism tells us the shape of the base. So this is our base right here. And remember, it always has 2 bases, so here's the other base. Find the area of the base. So we want the area of this triangle. Area of a triangle equals 1/2 the length of the base times the height. So here's our base, 12, and our height is 16. So the area equals 1/2 12 times 16. And if we type that in our calculator, we get 96. We were measuring in centimeters, and since area is 2 dimensions, it's centimeters squared. Find the perimeter of the base. So that's the distance all the way around. Now we know that the base is 12, the height is 16, but this side here isn't labeled. But it actually is because it's labeled on the other base. So we know the base is 12, 16, and 20. So our perimeter will equal 12 plus 16 plus 20. And we get that our perimeter is 48 centimeters. Now let's look at some area and perimeter related to circles. So circumference, which is abbreviated with a capital C, is the perimeter of a circle. So this is the distance around a circle. And it's also a one-dimensional item, so we're going to use units, centimeters, inches, feet. Arc length is a portion of the circumference. It's not the same thing. So if you wanted to think about it, it's got a circle all the way around, and we just want one little piece of an arc. So it would be like the length of a crust of a slice of pizza. A sector is the region bound by two radii of the circle and their intercepted arc. This is a two-dimensional figure, so we'll use units squared, meters squared, inches squared. And what this looks like is a slice of pizza or a slice of pie. So look at some formulas. For circumference, we have 2 pi r, or we can use pi d. So depending on whether we know the diameter or the radius, depends on which one we're going to use. So big C stands for circumference. R stands for radius. D stands for diameter. And this is our symbol for pi. Which, if you're doing it on your calculator, is the second button, and then the up caret button. All right, so before we can find the area of a sector, we have to find the area of the whole circle. So here we know that our radius is 3. So we're going to use our area formula. Area equals pi r squared. Our radius here is 3. And 3 squared is 9, so our area is 9 pi. And I'm going to leave the pi in there. I'm not going to type it in my calculator yet because we don't want the whole circle. And we don't want to have to deal with rounding till the end. We only want this section here that's shaded, which is worth 70 degrees. Our whole circle is 360 degrees. So we're going to multiply by 70 out of 360 degrees. And that will give us just this portion of our area. And when you type that in your calculator, the area of the sector is approximately 5.5, and we were measuring in feet, and area is square units, so it's feet squared. The next one says the area of the following shaded sector is 4.91 centimeters squared. Find the area of the circle. So since this is 135 degrees, we know that this angle here would be 225 degrees by subtracting 135 from 360. So whatever the area of the whole circle was, we took that and we multiplied it by 225 out of 360. And it ended up equaling 49.1. So we need to do some algebra to work backwards. To get the 360 out of the denominator, I'm going to multiply both sides by 360. Here they'll cancel out, and we'll be left with 225 times our area, and that would equal 17,676 divide by 225, and we get that area of the whole circle is equal to 78.56, and our units were centimeters squared. Finally, we're going to deal with arc length. So we've done a lot with arc measures and measuring it in their degrees, but depending on the size of the circle, the actual length of those arcs can be different. So in order to find the arc length of AB, so we just want this piece of the circle. In order to do that, we're first going to find the circumference of the entire circle, which we said circumference is 2 pi r. In this situation, our radius is 6. Multiply the 2 and the 6, and we get that our circumference is 12 pi. Now, we don't want the whole circle. We only want 135 degrees of it. So again, we're going to multiply by 135 out of the 360 degrees we have of the whole circle. And we'll get that the length of arc AB is approximately, when we type this in our calculator, we get 14.1 feet. This next one gives us the arc length and asks us to find the circumference. So whatever the circumference was, we would have multiplied it with 40 out of 360 degrees, and it comes out to equal 4.19. So just like we did in the area of a sector problem, we're going to multiply both sides by 360. Those cancel out. We're left with 40C equals 1508.4. Divide both sides by 40. And that tells us that our circumference equals 37.71 inches. Go ahead and write your summary.